Imagine walking into a big box store, picking up, what looks like a simple video transmission box, and seeing a $721 price tag.
Yeah.
I mean, you would probably just drop it and walk away, right? But today we are doing a deep dive into spec sheets and distributor data from HDTVSupply to decode a very specific enterprise-grade piece of technology. It's the Smart-AVI P2P-KVT300 transmitter.
Yeah, and we're going to figure out why it actually justifies that massive sticker shock, because this is definitely crucial context. I mean, this isn't consumer tech you just plug into your living room TV.
Right, exactly.
We are looking at really heavy-duty infrastructure meant to solve some, well, extreme physical challenges for massive commercial setups.
Okay, let's unpack this, because when you look at the raw physical capabilities, you start to see the engineering magic happening here. We are talking about taking high-resolution DVI video, up to 4K resolution at 30 Hz, plus USB 2.0 for your mouse and keyboard and analog audio, and sending it unthinkable distances.
Oh yeah, the distances are just wild.
Right, like over standard network cable, it handles a solid 100 meters. But it can also use single-mode fiber, which relies on a single, incredibly focused laser to shoot data. And that allows it to maintain those signals across a staggering 10 kilometers.
10 kilometers. That is over 6 miles. Sending uncompressed feeling 4K video and physical computer inputs that far in real time is, traditionally a massive bottleneck for enterprise networks.
Wait, I have to push back on the premise here. Why on earth would anyone need to control a mouse and keyboard from 6 miles away?
Like, instead of just using the internet?
Yeah, instead of just logging in using standard remote desktop software over the web.
Well, what's fascinating here is the mechanism behind the transmission. Standard internet-based remote software puts you at the mercy of external network traffic. You experience lag, visual artifacting, and glaring security vulnerabilities.
Oh, sure, the lag is the worst.
Exactly. But this device bypasses the internet entirely using ultra-low latency JPEG 2000 compression over a dedicated line.
So the JPEG 2000 compression isn't just making the video files smaller to save storage space. It is the specific mechanism preventing the latency you would normally get over a network, right?
Right. It is compressing the raw physical input and video feed in real time.
Think of standard remote desktop like sending a letter through the mail. It gets there, but the journey slows it down. This compression over a dedicated fiber line is like a pneumatic tube.
Oh, I love that analogy.
Thanks. The video and mouse clicks are vacuum sealed and shot directly to the destination with zero interference.
That pneumatic tube analogy captures the physical level control perfectly. You get the raw performance of a high-end computer without the actual hardware being in the room with you.
So we have solved the distance problem with lasers and zero latency compression. But if you have a massive server room sending data 6 miles away, you aren't just hooking up one solitary monitor. How does this device handle traffic control for dozens of screens at once?
It manages that scale through selectable modes like Direct, Matrix, and Savigate, which are all controlled via a web interface. Instead of just pushing video down a straight line, Matrix mode lets you route multiple remote computers to multiple screens.
Wow, so it acts like a digital traffic cop for an entire commercial network.
Yes, exactly, which explains the need for features like ED learning. It is not just passively sending a signal. The transmitter is intelligent enough to talk to the displays on the other end and ensure the video formatting is automatically optimized for whatever specific screen it hits.
That is super smart. And since it is powering complex physical spaces, it features military-grade electrostatic discharge protection, withstanding up to 30 kilovolts of static electricity. So what does this all mean for you, the listener, if you are trying to wrap your head around massive AV systems?
Well, if we connect this to the bigger picture, look at the commercial space's HDTVSupply targets. Giant sports bars with 80 TVs, complex industrial control rooms, or massive multi-screen video walls.
Places where you really don't want the computer sitting out in the open.
Precisely. This device turns a highly secure remote computer into a flexible multi-user environment. The physical computer can be locked safely in a climate-controlled server room miles away from the spilled beer of a sports bar or the dust of a factory floor.
But the user operates it as if the tower is sitting right under their desk.
Right, exactly. It's totally seamless.
Summarizing our deep dive today, the Smart-AVI P2P-KVT300 is a heavy-duty plug-and-play solution for extreme distance workstation management. Suddenly, spending over $700 on a little black box feels less like buying an overpriced cable and more like investing in absolute structural reliability.
For sure. Understanding how dedicated fiber optics and zero-latency compression work together is vital to building out modern AV infrastructure. It really is engineering precision solving very physical limitations.
Which leaves me with one final thought for you to chew on. If a localized device can seamlessly transmit 4K video and instantaneous physical computer controls over 10 kilometers of fiber today, how might this tech evolve to completely erase the physical distance between humans and high-powered computing in the future? Are we moving toward a world where the physical computer itself is entirely invisible to the user,